let's see. I guess we're live. Hello from Emerald Hill Skies. My name is Doug, and welcome to tonight's broadcast. We're going to try to look at some comets and also asteroids. We should have named it Comet and Asteroid Night. I'd like to welcome our community that's already here. It's so hard to believe you guys are so kind. Tiffany came on and started greeting people. It's kind of like, Tiffany, you're like at the door of the party, like welcoming everybody in. Larry, it's good to have you aboard. And John, good to have you aboard too. You were right about those hairy stars. I think that's actually what the word coma means, I think. Let's see. Ray, good to have you on board from Arizona. Let's get started. You know, we observe from the outskirts of Louisville, Kentucky, and we use a RASA 11. It's an 11-inch Celestron RASA scope, Rowe-Ackermann Schmidt Astrograph. And tonight's a beautiful evening. It's absolutely jet black. There's some city light pollution you can see down there along the horizon of this Skycam view. But we do use a light pollution filter, so that helps us a little bit there. And we're going to use Sky Tools as not only our guide for the night sky to be able to figure out which target is next, but also for our charting, journaling, log entry, and then also it's got a built-in atlas, so we'll be using it for that as well. So let's see, here on the screen, while I was getting things warmed up, I just opened the scope up and set things on Vesta. And so you see Vesta right there in the middle. If you look over here at the right, you're getting just a little peek of the Atlas program that we use. I'll kind of pull it over here for a moment just so you can see a little more of it. This is what we use to get an idea. And all these stars have names and way tiny letters down here in the lower left-hand corner. You can read off the name of every little star. Like that's got some long name, J05225.4.1 plus 223000. It's the name of that little star. But this is Vesta right in the middle. So I'll move this over here for right now, kind of out of the way, and see if I think if I put it right. Where do I need to put it again so that when, oh, okay, so maybe somewhere right about there. And then when we bring that window to the front, you can still see the main target there. How about that? So that's Vesta. And how do you know that's Vesta? Well, it really hasn't moved a lot. We could zoom in some more. Let's go into, this is a live view that you're looking at here. There's 200%. Still don't see a lot of trail, do we? Now we're getting to the point that you can start seeing little pixels. The only way you would know that that's Vesta and not another star is look at the size of it. It's just bigger than a star point. Even these brighter magnitude stars are not as wide as this one. I've been stacking this with 20-second exposures now for 36 minutes. And you still don't see a lot of trail. I guess that's because asteroids are moving much, much slower than comets. So there you go. That's Vesta. And let's go ahead now and see. Let's just do a quick log entry there. Create a log entry. And we're going to just say something like in spite of stacking for 37 minutes, we still didn't see any star trail on this asteroid. But it was sure wider than a star. Just a little bit wider. Okay, so I think that saves that automatically. Oh, here we go, close. And then we don't have that. We don't have that showing a log entry, so I'm just going to put a check mark there. Now let's go to the next one, and it's supposed to be, let me look at its height, at 47 degrees altitude, and its magnitude 11.6. Why don't we stop the live stacking here? Okay, so here we go with the next one's going to be Scope 2.
The telescope is slewing.
And this one is called C slash
Viewing C/2017 K2 PANSTARRS.
K2 PANSTARRS. Okay. You know, maybe you noticed I did get the
Viewing C/2017 K2
I did-
PANSTARRS.
I did get the night vision, whatever you call it, worked out for our sky tools. It was just a question of turning up the brightness of the red, so it really wasn't a very big deal once I got it figured out. Let's see what's happening over here on you guys' stream. Larry, Bowling Green, Kentucky. I didn't realize how close you were. Ricky, good to have you aboard. Clear ambient skies. Good to see you again. Doing just fine on this end. Dane, good to have you on board from way up north. Let's see. Okay, so right there in the middle, see that little, let's zoom in to 100% first. See that little greenish dot right there in the middle? It'll become a little less grainy in a minute, but that's our comet. Comet 83489. I don't know if we'll see any aliens or not, but we're going to try to see some comets and asteroids. Susan, good to have you on board from Arizona. Welcome. So this is PANSTARRS. Let me make this primary ID a little bit wider here. And then I wonder if I need to close this first, or if I can just, with that highlighted, I'll just try to hit. Yeah, it switched without me having to close it. So, if you try to just quickly do some human plate solving here, try to find a shape of stars that makes sense to you. Like here's a bright star with a tiny star next to it, and there's a kind of a medium star, and then a bright one. So you look over here now at the live picture. So this is our live picture. There's the bright, the tiny, the medium, the bright. So this little array of, whether you count that 4 or 5 stars, I guess with this star here, that's that star there, that little array is to the left of our comet. And sure enough, you see this is to the left of the comet right there. Now this comet doesn't have a very classical tail, does it? It's just kind of got a greenish tinge, which probably means, what does that green mean? A little more like in the outgassing that's coming out from the middle of the comet. Wouldn't that green represent something other than hydrogen? So probably oxygen or carbon dioxide maybe that's outgassing. And then what happens is, when it outgasses from inside of the rock of the comet, the icy snowball of the comet, then immediately it cools off so much that it, what they call, I think, sublimates. And some of the gas is ionized, which makes it kind of glow in the dark. But some of the other gas and particles are caught by the, I guess, the reflection of the sun a little bit. So that's where you get this, this greenish tinge, is that outgassing. It's not a classic comet tail. We've been on this 4 minutes, and this comet is just 11.6 magnitude. It's only 1.2 arc-minute wide, but you can definitely tell it's a different color, can't you? All the stars around it are kind of whitish, and this one in the middle is definitely got that greenish tinge. C/2017 K2. I'll kind of zoom in here for a second. C/2017 K2 PANSTARRS 2017. Oh wait, that's the next column over. Let me make this column wider here. Yeah, C/2017 K2 PANSTARRS. I think the C would kind of, does that represent a comet? And then the 2017 is the year it was discovered. The K has to do with the month, and I think it's A, B, C, D. So January, February, March. So A, B, C, D, E, F. That would be March. G, H would be April. I, J would be May. K would be June. I think it might mean that it's discovered in June. And then the 2 would be what? The second day of the third week. I think that's the way it's set up. And PANSTARRS, isn't that the name of the kind of lab or else the person? If it's discovered by a lab or observatory, then it's going to have a name like PANSTARRS. But if it's discovered by a person, then it'll actually have the name of the person there. It's in the constellation of Orion. So let's switch this for a minute. Let's come off of this and let's go to the, what would we use there? The view overhead sky or view naked eye? I think we decided the other night we liked the naked eye better. There we go. So if this is your western horizon, if that's looking south, then as you look up, it's kind of right off the belt of Orion. So you can find those 3 belt stars, and you just go to the right of those. Here's the brightest star, would be Sirius. And opposite Sirius, shooting off those belt stars off to the right, not too far from the shoulder and the foot of Orion, in other words, Rigel, would be this comet C 2017 K2 PANSTARRS. So kind of fun to see that. Tonight, by the way, it's about 39.9, so almost 40 degrees, 63% humidity, pretty high humidity level, huh? So the dew belt is working again. All right, so that's as good of a job as we're going to get. There is a little bit of movement, by the way, now. Look, take a look. Look how this comet is already moving fast enough that in our 7 minutes, it's already now the beginning of an oval shape. You know, instead of just a dot, you can tell it's now oblong. Just after 7 minutes. So that's amazing how rapidly this comet is moving. All right, so we're going to do a little observation log on this. Create log entry. I'm going to say we could see clear Gotta learn to.
Telescope position synchronized.
Yeah, I gotta look. We could see clear movement after just 7 minutes. C 2017 K2 PANSTARRS was already moving in a line that would be away from that fence of neighboring stars. I think that would be east. I'm not sure about that. We'll pull up the atlas again to be sure. I think it's A for atlas. Yeah. So let's see. North is here. No, it's flipped. So it'd be moving northwest. Northwest. I'm gonna see if I'm trying to do our log differently. I'm gonna see if I can pull that log entry up again. The other night, I have to create a new one to get to the first one, and then yeah, northwest. Northwest. Look at that movement. Look at it darting. Relatively speaking, it's darting. It's moving out of alignment with the stars because it's a solar system object instead of a star. Oh my goodness. Camus 83489 pitched in $5 and asked if we go to the Orion Nebula. Camus 83489, absolutely. If you're going to pitch in $5, let me look and see what you guys have been saying here. Susan, yeah. Jeremy, do the comets have a visible tail? Well, we're going to find out. I mean, this has definitely got a hairy-looking thing around it, doesn't it? Even though it's not got a tail per se, but it's definitely got a little fuzz. Let me see if we can make the part around it, the sky, a little darker. And maybe that, we can make that fuzz pop a little more. Not much before. You can definitely see that it's going in a line there though, can't you? The telescope tracks the night sky, Camus. It doesn't track with the comet. Big Show, good to have you on board. Big Show wants to see K218b. Jeremy's saying your Shih Tzu is cute, Tiffany. Just to make sure, catch anything else. Jeremy's in Southern California. And Lucky Me from Vegas. Hey, you're getting ready for the Super Bowl, right? Big Show is in Toccoa, Georgia. All right. It has an aura. That's the best way to say it, Susan. An aura is the absolute best way to describe it. Okay, we're going to stop the live stacking now and go to our next object. And so the next object will be, let's find something that's, I guess would be this C1917 H1 Schaumasse. 1917 H1 would be an alternate name. It's also an Orion. 90,000 kilometers wide. It's supposed to set at 2:03 a.m. It has an altitude of 46. Let's go there. Okay, so it's not very far away, actually.
The telescope is slewing.
Very tiny movement.
Viewing C/1917 H1.
Yeah,
Schaumasse.
see, it was very slow. Let's go put the name in here again. C1917 H1, and then Schaumasse, Schaumasse. This Sky Tools software, I'm really liking it. Up here at the top, you can see an attempt to graph when the object is at its best. And this little line here shows the best time to see this object. And then I believe this line, this dashed line, represents its ascent in the sky. And then this line would represent the sun setting. And then over here, this line would represent the moon rising. So we're doing great to see it right now. Those colors are not very good because we have it in night vision mode. And in day vision mode, it's a lot more colorful. Okay. We don't have to do a lot of adjusting of the screen. This one's going to be magnitude 11.5, a little bit harder to pick out. Why don't we do I wonder if this is already, it should already be played solved. Yeah. So what is this going to look like here? What we'll do is we'll come over here to our atlas and we'll hit the A button, and then it should, wow, so look how it's trying to point out the comet, but we have to zoom in quite a bit to see it. What do you think of that? So it's basically, oh, there we, back out to, there's our field of view. This is going to be very, very, let's get enough stars that we can do our, we can find our shapes again. Okay, so doing our human plate solving, look at this shape here. It's kind of like an arrowhead pointing almost right at the comet. Okay, so now let's zoom in on this. So I'm going to guess that okay, look at these 4 stars here. There are those 4 stars there. Here are these 2 and that dot. So from this 4th star there, this is like human plate solving, isn't it? These 3. You know, I have a good friend on the Isle of Wight, and he made me a nice little deal to pull over information from Stellarium into SharpCap so we could see an object have crosshairs right on the map. And then I went and moved from Stellarium, and I'm using this atlas. Just got so many more stars, though, doesn't it? I just like the fact that it had so many. Okay, so, and that, his name is Pete, and he's a great friend. And by the way, his wife and his daughter watch sometimes with him as well. So hello to his wife and daughter. Look at the way this little shape here has this little inner bow to it. So here's the outer bow, and there's the inner bow. And then here's this little these three stars, and look how in our picture there are those three stars, and then there's supposed to be these little stars right here, but look how that one is so bright. And then these two stars. So right there is our comet. And how did I know that? Because there's not a star in this atlas in that position. You have these three stars, and then you have this little arc going away, but that star is not in the atlas. And here's where this crosshair is trying to light it up. Now they don't have a pinpoint there in the atlas for the comet. So we just have to realize that the atlas is not putting a pinpoint there. So this is our comet right here. Now this one's not as green, is it? But every comet is different. You look and see what you guys are. Our Celestron RASAs made in America. I believe they are assembled here at last, but I think most of the parts are not. They are made, I believe, in Asia. Comets are one of my favorite. Walter, this is your night. Hadn't seen Sky Tools before. Looks pretty useful. Using the visual version tonight. Yes, I finally figured out how to use that night vision. Larry, good memory. Your RASA is talking. Yeah. In fact, listen to this. If you want to hear more, Dane, listen.
C/1917H1 Schaumasse is a comet, located in Orion. It is magnitude 11.5. This comet is 125.2 astronomical units from Earth, and 125.7 astronomical units from the Sun. The orbit is inclined at an angle of 159 degrees to the ecliptic. This object is moving slowly at a rate of 18 arcseconds per day.
There you go.
In the following 30 days this object is apparent visually from February 6th on, with the best view coming on February 6th. During this period it will remain constant in brightness and will remain constant in altitude. C/1917H1, Schaumasse, is past perihelion, which occurred in mid-May 1917. On 1917 May 18, 1917 this comet passed within 0.40 of the Earth. It reached maximum brightness of magnitude 7.5 in late May. The best visibility from Emerald Hills near maximum brightness was predicted to be in late May when it was approximately magnitude 7.5. On May 23 this comet was moving quickly across the sky at a peak rate of 18.0/min p 86.2 degrees.
So it got to mag 7, so that's really bright. So it's headed away from us now. No apparent tail or aura, as who was that talked about the aura? Was that Susan, I think, used that name. No aura. Actually, I don't think it's a supernova. So that is Sky Tools, Larry, that's doing that narration. Okay. So it's kind of fun, although it doesn't have a tail. It's fun to see like this wandering object out there, isn't it? It just did not have a place in our star chart. All right, so now let's go to 144P Kushida. We'll close out the live stacking first. And then head to 144-Kushida.
The telescope is slewing.
This
Viewing 144p/Kushida.
Sky Tools will even tell us how far of an angle it is to slew to the next object. So that's pretty useful. That way you can sort of plan your slewing so that you go in an order that's less work, less time for the telescope. So that's pretty cool. So I'm going to type in this name, 144P Kushida.
Viewing 144p/Kushida.
So it's in Taurus, magnitude 10.7, has an angular size of 3.5 arc minutes. So what is that? 111,000 kilometers from us. It's about 3/4 of a distance of an Earth orbit. It's called an astronomical unit. It has a 7.5-year period. So wouldn't that be a very short period comet? So it comes around quite often, huh? Oh my. That's a nice shot of it, isn't it? Right from the first, well, that's not, but let me get this, look at that right in the middle. Before we even do anything, you can already see it. So Susan, there's your aura back again. Wow, that's a much bigger aura, huh? So bring up the atlas for this object. And look, this map even shows the direction that it's moving. So you can see that it's, and we might have to do some playing here with the direction, because see, here are the two stars here. So again, you have to start looking for your human plate solving, what would you call those, like markers, or what name we're going to use for these little signposts. The camera, by the way, is the ASI2600MC Pro. It's a ZWO product, ASI2600MC Pro. That was Comet 83489 that was asking that. The narrowband filter, it's actually the Celestron light pollution filter that's made for the RASA 11. It's specifically made for this telescope. And that's all we've ever put in there, and we just stay with it. Now we don't have to walk the 200 feet out to the observatory, because literally we'd have to go walking out there 200 feet away to change the filter and then come back inside. That wouldn't work very well. So we just use that one filter the whole time, and it is the Celestron light pollution filter for the RASA 11. Yeah, patterns, that's a good idea. You're going to look for patterns. So these two stars here, now notice how, because it's an equatorial mount, and the way the mount works, See how it's on that those weights that swing back and forth? And because it's always changing from one side to the next, like right now, the weights are headed toward the west. But on another object, the weights might be Pier east. So you can never tell for sure which way is going to be north. So you just have to work it out with the signposts, you know, the pattern of the stars. So here are these two stars, and there are those two stars. Then you have this fence here of 4 stars. And here is that fence here. The 4 stars just slightly off the screen. So here are the 3 stars. Then you have these 2 stars, which are these 2 stars. And in the little blinking crosshairs are showing you where to look for the comet. But we really don't need very much of a blinking crosshair for this comet. This thing is absolutely lighting up the whole area, isn't it? That entire area of the sky is just being illuminated by all that outgassing stuff. Now, you know, I've always wondered what it would be like to stand on a comet, but which spacecraft was it that tried to actually latch onto a comet? It seems to me like it was called Vega, was it? Vega, I can't remember which one. It hasn't been that long ago, and it's like 2014 maybe, I can't remember, and it tried to land on the comet, but it couldn't latch onto the surface, so it ended up kind of bouncing off, and that was sad. But we did learn something from that. It's like the comet had a harder surface, and the theory is that with all this, what would you call that, sublimating material, it sort of forms a crust of the outside of the comet. And that crust might actually be very dark. We look at a comet and we think it's glowing, but it's really not. It's the sublimating materials that are being spewed out by these gas jets, and that's what's glowing. But the actual surface of the comet is more like the crust of what can we compare it to? Like on your gas grill, the way that the carbon forms, and you have to use a wire brush or even a scraper to get the black crust off. Well, that's the kind of thing that was on the outside of this comet. And it was pretty hard, harder than what they thought it would be. Some people thought that the comet would just be sort of like soft and absorbing, kind of like spongy, but it wasn't. It was like the crust on a gas grill. So now you can start to see at what? We're at 6 minutes, and look how we're just barely starting to see the elongation now of the pattern of the comet. And if we look at this line in Sky Tools, it's showing us the direction the comet's going to fly, and look how it would be off to the right of these 2 little signpost stars here. And sure enough, that's exactly what Sky Tools is indicating, that the comet's heading in that direction. You can see the way this is elongating in exactly the predicted direction. So that's kind of fun. Again, I like Sky Tools because it's got this really more attractive night vision mode. And I can't find another charting software that does that. But I also like it because of its unified object list. All of the objects are cross-listed, so you don't have multiple listings of one particular target. They're all cross-matched. But the third reason I like it is for the atlas. It's worth getting just for the atlas alone. And again, we can also look at the naked eye view, which kind of shows us where we're looking at in the sky. So right here is where the comet is. If you look over toward the western horizon, a little bit south of west. So again, we traveled a little bit farther from the belt of Orion, and this time now, look at the bow and arrow. Orion's bow and arrow. We're going in the direction of the bow and arrow, and we're right here in the middle of this constellation Taurus, the bull. And what would those be, his horns? And we can see that that's Aldebaran. It's a little bit brighter star there, Aldebaran. And I knew that because this atlas just shows you when you hover over it which object you're looking at. So kind of interesting, isn't it, to be able to see the context of the night sky and then immediately go to the close-up. So we'll do, did we do a log entry of this yet? I don't think we did. So do a quick log entry and we'll say elongated. Now this time I'm watching for the refreshing because it refreshes and it removes the focus from the elongated after just 7 or 8 minutes. Traveled exactly in the direction predicted by Sky Tools. Oh, I see. So you have to say close for it to save the log entry. Okay, now we did have a request. I don't want to forget. We had a request from Camus 83489 just to see the Orion Nebula real quick. So I'll tell you how we would do that in Sky Tools. We say add an object, and we're going to say, now that's not visible to you, is it? Because that's a new window. In my search window, I'm typing M42 and then adding that to the list. And then we're gonna, oh wait, let me stop the, boy, that's beautiful. Let me do a quick picture of that. That's really awesome. You can see all that greenish glow of whatever, that's like ammonium or ammonia or some kind of methane maybe, or just carbon dioxide or a mixture of all the above as it's being lit up by, you know, like ionized by the sun. This is M42, the Orion Nebula, and now we're going to slew there.
The telescope is slewing.
This is a security camera,
Viewing
and
Orion Nebula.
And I'm liking it a lot more. It's color. It's very, very night vision sensitive. Look, the moon's not even out tonight. That's just like light pollution lighting up the sky. That's all that that security camera is picking up. There's no flashlight on that scope. So I really like the way that security camera is functioning. Okay, so right from the beginning, you can see this is an incredibly bright nebula.
Viewing Orion Nebula.
So there it plate solved so that it would center it for us. All right, I'm going to catch up on the cue here. Green, Dane, I bet somebody's going to pitch in. The green color is not moving toward us. Yeah, the sun illuminates the coma, the glowing atmosphere around the comet's head, right? 2400 MC. Boy, I don't want to buy anything, man. This stuff is too expensive. The coma contains high concentrations of cyanogen and diatomic carbon, which glow green when illuminated by the sun. The phenomenon is called resonant fluorescence. Love it. Thank you, Clear Ambient Skies. The RASA is hard to collimate. Boy, it probably took me 3 nights. And it's not because the controls are bad, it's because the range of acceptable tolerance is so small. It's the range that you're working with is the thickness of a human hair. You're literally trying to align the sensor of the camera exactly with the mirror with a tolerance of the thickness of a human hair. And I might add, your grandmother's hair. In other words, very thin human hair. I mean, you're right, Claire. I mean, guys, I don't ever adjust the mirror itself. It's just that optical train alignment. That's exactly right. Right. Clear ambient skies, right. You don't have to align the mirror. It's just, when I think about collimation of a RASA, I'm kind of lumping it together with the idea of aligning the sensor. Yeah, Newtonians have a lot more tolerance. Camus has got a 12-inch dial and a 6-inch Virtuoso F5. $620mm, yep, for the RASA. Scope envy. Tiffany's got scope envy. Okay, so here's the Orion Nebula. Let's just do this reset here and reset there, and then color match here. And then we'll right away pump up these mids. So you can pretty much decide, do you want to see like the trapezium, which are those stars that are here in the middle of this nebula that are backlighting everything up, or do you want to see all the clouds that they illuminate? Now this is actually 2 different nebulae and a couple of star clusters too. In fact, let's just plate solve this real quick and turn on the deep sky image annotation so that we can see. We zoom in here a little bit. You can see this is M42 here, but doesn't this nebula have its own name out here, if I remember right? I was thinking it did, but it's not identifying it in plate solving. Let's just open up this atlas real quick and M43. I thought it had a separate name. So I think this is called maybe M43, and this part is called M42, but I don't see that in Robin's. I don't see M43 noted in Robin's deep sky image annotation. A lot of objects in this frame. You can also see the famous Running Man Nebula over here. And this Running Man Nebula is supposed to look like, you guessed it, wait for it, a running man. Now, I want to be honest with you, I'm never quite sure. Never quite sure that I'm making out the running man. So the running man nebula should be, I think, right. Let's see, 1977. This is 1973, NGC 1973. I think this object here, this bigger object, is supposed to be the Running Man Nebula. I'm never quite sure I'm able to make out why it's called a running man. Let's get rid of the deep sky image annotation, and let's just focus here for a minute on this object. And we'll turn up the mids a little now and see if you can help me understand where is the running man. Is he maybe upside down? Maybe that's the trouble. Are these his legs? Is that it? Is that why I don't ever see it? Is because he's a running upside down man. Boy, that lights up well when you really pump up those mids, doesn't it? That's a huge nebula, isn't it? Just the Running Man Nebula alone. I'll go over here to the Atlas. Quite a bit here. All of these are so much nebulosity here. Yeah, I need a little more practice with this Atlas, don't I? Still getting used to that. So anyway, I'm going to see here, yeah, upside down. So Ray's helping us out. Legs are on top. Yeah, flip vertically. All EAA, Larry, never any imaging. Certainly is beautiful nebulosity, isn't it? That's just 8 minutes. What an amazing part of the night sky, right? I think those are turned up a little bit. Of course, you saw the map in the Atlas. What this map is basically saying is anywhere that's red is nebulosity. So it's basically saying this whole thing is just lit up hydrogen gas, every bit of it. So it's no wonder that when we look at this, look how this kind of has a cloudy look to it. All of this outlying area is still nebulosity. It's a star-forming region. Just a gorgeous part of the night sky, isn't it? Look how here, when you get out here in these pinks, and that's just 9 minutes. It's just that this is such a bright nebula. It's so close. See if we see the distance over here.
Orion Nebula is an H2 region in the constellation Orion. It is magnitude 4.0, with an apparent size of 40 by 20 arc-minutes. This object was discovered by Nicholas Pires in 1610. The Dreyer summary reads, a magnificent or otherwise interesting object Theta Orionis and the Great Nebula. Orion Nebula is also known as M42, and NGC 1976. Note brief from, my attachments. 0957.
Okay, so 1,500 light years, Ray says. All right, off we go, because we have comets to catch. So we're going to save this just in time. Add a little satellite trail here. That's okay. That's just part of the night sky. Is this... What star is this? This real bright one here. Is it that? So it... Maybe it's not even a named star. It's just a number. Now this does have images. I just don't have them turned on. I kind of just like being able to see the patterns as is for right now, but maybe later I'll turn on those images like Stellarium has. Let's just do a quick log entry there. Oh, I see. So you don't have to use create log entry, you can just say quick log entry. I was thinking like Pete and I use in Astro Planner, a quick log entry just basically says, okay, observed it. But here with a quick log entry, you still get to say something. Finally understood Running Man upside down. Thanks to the community of observers for helping me. Ray. Beautiful. Beautiful night sky, huh? Okay, off we go. So, thank you so much, Camus, for asking for that. Okay, next on our list is 103P Hartley.
The telescope is slewing.
103P Hartley. 103P Hartley. This is at an altitude of 42 degrees, about 20,000 kilometers out. Oh, no, 20,000 kilometers wide, sorry. It's about 1 astronomical unit away from us. So the distance would be 8 light minutes away from us. Has a 6.5 year period. So again, it's a short period comet. You know, the way these short period comets work, as I understand the way these short period comets work, I think they originate from the, oh, what is that band called? You've got the Kuiper belt, and then you've got another band of objects. And the short period objects originate from that band, I think. And they get thrown around at us. I think they get thrown in toward the sun by, theoretically, we believe they round something like Neptune, and that gravitationally throws them at us. What is that band called? Outside the Kuiper belt is the, oh, it's something like near
Viewing
objects.
103p/Hartley.
Near objects. No, I think, Ray, the Oort cloud is actually way far away beyond that, and it's more spherical, and I think, if I remember right, the Oort cloud is where the long period comets come from. And they can be, say, more than, like, extremely long period, like way long period. But these, I think these shorter period comets come from a belt that's out beyond the Kuiper belt, but not as far as the Oort cloud. Yeah, 92 million miles. Okay, this is a pretty star-rich part of the sky, isn't it? My goodness. This one's going to be a little harder to detect, isn't it? Okay, here we go. What a star-rich part of the sky. Okay, so let's see. It is along an arc of, look at that line. So we could find a line, 1, 2, 3, 4, 5, 6, 7 bright stars, almost an arc with that brighter one there. And that's, let me make sure I get the, wow. There's so many stars for it to draw. That's supposed to be the RASA's frame. Boy, that's, if we can find that line. Look, there's a yellow star. Okay, let's look over here. We've lost a little of our focus, haven't we? Let's check that temperature. Let's see. Yeah, 38. All it takes is 2 degrees. I've noticed that. Once you get 2 degrees different, you've lost focus. Okay, we can do this, guys. Like here's a line of stars. Could that be it? Boy, our focus is just really gone. Okay, so in this line, 1, 2, 3, 4, and then it's a double. That could be that double. And look, it extends 1, 2 with a line out of the side. So Pete, bow my hat to you, and we are human plate solving here, I recognize. Okay, so the comet should be it was predicted to be boy, the focus is just so bad. I thought maybe that was it. That is it. Right there is it. But the focus is so bad. This is 13.5 magnitude. So we really need our focus to be tighter. Of course, I'm at 241%. Let's back down to 100% so we look at our optical zoom at its height. So that's the limit of our camera in its optical zoom, and right there is the comet. So you have that star, and then these two with the comet in a triangle. That star, and then these two with the comet in a triangle. And it's moving that direction. So there's our comet. This is not as impressive, partly because the focus is so bad. We'll focus after we're done here. But 13.5 magnitude is actually really dim, and this is a satellite trail across our field of view here, but at least we know we located it. See what you guys are saying here. Scattered disk. That's it, clear ambient skies. Scattered disk. 92 million miles the distance from the sun to the Earth, and also the length of an astronomical unit. Right, Walter? Okay, so clear ambient skies, early day in the office tomorrow. Thanks for stopping by. Yes, astronomical unit, right. All right, so what we're going to do here is just, by the way, I'm going to try this quick. So that's L for log. Wow, that goes right. You skipped that middle screen. That's a lot better. Boy. Boy, our focus was way off by the time the temperature had dropped 2 degrees. But we could still make out the fuzzy, faint comet through human plate solving, as Pete calls it. Not that impressive, actually. Just a fuzzy aura, as was it Susan? Can't remember. Who helped us invent the word aura? Was that Susan? Yes, Susan. As Susan put it. Ray, we do have autofocus, but now that I've been live stacking, it won't help to focus with the bad frames. So we've got to stop live stacking. And then if you're going to stop live stacking, the way I look at it is you might as well stop the whole procedure and
Viewing 103p/Hartley.
turn off the camera as soon as I can get control of the cursor back from the silly sequence. Hello. Hello. Now see, that doesn't look so bad, does it? What if I just hit stop? Does that stop the... No, that didn't stop the telescope. Okay, and then we have to turn off the camera, remember. We have to go to Nina. And then will it let us grab the focuser? Yes. And then this autofocus in Nina just works so well. It's worth that little, yes, Susan. It's worth that little detour just to be able to have this focus. By the way, I did finish the list for this new list, 1001 Celestial Wonders to See Before You Die. I got it all finished, and I actually sent it to the developer of Sky Tools, and he made a comment about it that it was impressive. He said, that's a big list. It's about actually 1,010, was it 1,010 objects? Because some of the objects have multiple targets in the same listing. But I really like it because it is comprehensive. It has not only around 500 objects that we've already looked at, but another 500 that we haven't. So I'm really looking forward to going through it. It took us a long time to do the Herschel 400. And by God's grace, we finally did finish those 400 targets in the Herschel 400. But this is just so much bigger, as you can imagine. The Messier list is 109. The Secret Deep list was around 109. I think the Hidden Treasures was around 109. The Caldwell list is around 109. So those lists are all roughly the same size. The Herschel 400, it took it to a whole different level, didn't it? It took forever. I think maybe it took a year and a half to do the Herschel 400. But to be fair, we were still in a heavy, heavy learning mode. I'm just counting on you guys now to help us with this. And I hope we've learned to go faster. And you know what I've been wondering about? When we start this list of 1,001 objects, I'm thinking about doing them all from scratch and not starting with just doing the 500 that we haven't logged yet, but doing all 1001 from scratch as if we haven't logged any. And that way, if you've just joined us in the channel, you can go through all 1001 objects with us and see them all in one comprehensive list. So I'm really looking forward to this by Michael Bakic, and he writes about maybe anywhere from one paragraph to maybe 2 or 3 paragraphs about each object, and I think that's the right speed. You know, there are times in the Steve O'Meara books where there's just so much text about any one particular object. There's no way that we're going to be able to read all this text in a live stream like this. And I felt the same way with, again, the Caldwell list. There's just so much text. It's really for a deep dive, one object at a time, which has its place, mind you. But I think if we use the 1001 Celestial Wonders to See Before You Die, we can just look at those 2 or 3 paragraphs max at a time, and I think it'll go by pretty fast, and it'll be a good kind of modicum of, yes, some information, but not too much. Boy, this is a very strange parabola, isn't it? I wonder why it's Ray says, I also do my focusing in Nina as well. It's much faster than the sharp cap autofocus. We do some art galaxies, Camus, but tonight we had sort of hoped to do comets. Just think about how many we'll see after we die. That's right, Walter. I was thinking, I want to do a night coming up, just maybe a couple of live streams from now, on objects that we've learned about from the James Webb Space Telescope. So we'll do that one night. That's when you get out the highlighter and pick and choose. Yes. What is up with this up and down parabola? This thing was all over the charts, wasn't it? What we do in Nina, I think the way we have this programmed is we do 2 quick pictures and then sort of average between the two. And I guess if there's a, what? Some kind of sky perturbation or, turbulence in the sky, then that might throw off that particular focus. But even with those being thrown off, you can see how Nina is trying to guess where the focus is with this hyperbola or whatever it's called here. It's trying to guess the focus. Okay, so it's done. That's the best guess it did. Shall we take that, or do you want to try one more? You guys decide. Want to do one more? Let's do one more and see if we can improve on that. Let's try it. Let's see if we can do one more. And let's talk one more time about comets. So help me remember, what if it's longer than a certain amount of time, it's called a long period comet. Is that, I'm trying to remember, is it 200 years? Somebody help me remember. If it's a long period comet, I think the break is 200 years. Then the theory is that that comes from the Oort cloud. And then the question is, well, how did all those objects get out there in the Oort cloud? Because the Oort cloud, remember...
Hartley.
Oh, so it's still trying to... Maybe that's the problem, you think? Maybe the... Do you think that Sky Tools did something? Maybe we need to take the telescope control away from Sky Tools when we're autofocusing. Close connection.
Telescope disconnected.
Because I think what Sky Tools just did is it moved the scope a little bit, you think? Surely it wouldn't have done that on us. But that would definitely mess up the focus, wouldn't it? Was it slewing? Oh my goodness. You know what happened, I bet? I bet it was a meridian flip. I bet it wasn't Sky Tools' fault. It was just that it was a meridian flip. And that's what threw off our focus. So let's stop out of this and let's start again. Now that we flipped, now let's start a clean. I wondered what was messing that up. Chris, you're never too late to join Emerald Hill Skies. So a meridian flip is when the weights of the telescope have been Pier East, and the telescope is trying to track with the sky, and as the telescope backs up and backs up and backs up, it's finally backed up so high, it's got its head against the back of the hinge, so to speak, and it can't go back any farther. So now it has to flip around and put the weights west. And what Ray is saying is that he saw that it was slewing. So I bet the focus was messed up because it was during the time that it was slewing. And of course, obviously, the focus routine depends on specific stars that it's picked. And it tracks with those stars and decides what is the half width radius luminance of each star. What it's basically trying to do is find a place where the stars generate the smallest disk possible. Looking at the half, what are those initials? Half width radius, is that what it is? So it tries to find the place where the stars are as narrow as possible, as pinpoint as possible, and that's the definition of sharp focus after all, isn't it? Anyway, we were talking about comets. Okay, so here we go. Ray says the Oort clouds, the Oort cloud comets can take as many as 30 million years to complete one trip around the sun. So that's your long period comet. We'll see one time in our life. Whereas your shorter period comets, and I think the breakpoint to define shorter period is less than 200. The shorter period comets are like Halley's. And what is Halley's comet? 76 years, something like that. So you can literally see Halley's comet twice if you are born in the right time and you play soccer or something to keep your heart healthy. You can maybe see Halley's twice. And then these other comets, like this Hartley that we just saw, that has a period of just 6.5 years. So it's a fairly short period because it's coming from the, what was that place called again? I can never remember. The scattered disk. How will we remember that? I'm never going to remember the name of that. Scattered disk. Why couldn't it have been named after Ray or after you, clear ambient skies? But instead we've got Kuiper belt, scattered disk, Oort cloud. Why? Anyway, the scattered disk, the comets that come from the scattered disk are much shorter. And Stu, you're on. Stu, good to have you on from Tauranga, New Zealand. The short period comets are found near the ecliptic, which means they're orbiting the sun in the same plane as the planets. The short period comets are thought to originate in the Kuiper belt and the scattered disk, I think, also, Stu, less than 200. Okay, so it is the 200-year breakpoint. Thanks, Ray. All right, so I think this focus is going to be a little more reliable than the one that we did during the meridian flip. So it's going to just turn the corner on this bottom of this hyperbola, and 4 focus points later, now we're down to 37.4, so it's almost 3 degrees drop now. The next comet, actually, if you wanted to, we could just stop by Uranus on our way to the next comet. It's at about 20 degrees above the horizon, but we should still be able to pick it out. Let's just stop for a moment at Uranus. You know what we really want to make sure we get to, though, is this (62p) Tsuchinshan. How do you say that? Tsuchinshan. It rose at 10:30, so it's only up to 24 degrees, but that's high enough. We want to make sure we get to that. And why do I have NGC 4216 in here? What is NGC 4216?
NGC 4216 is an edge-on spiral galaxy in Virgo. It is magnitude 11.0, with an apparent size of 7.8 by 1.8 arc-minutes. It is 31,000 light-years in diameter. This object was discovered by William Herschel in 1784 using an 18.7-inch telescope. The Dreyer summary reads, very bright, very large, very much extended 17 degrees, abruptly brighter in the middle nucleus. NGC 4216 is also known as McG 2-31-72, and UGC 7284. Note brief from My attachments. X.
I don't know why we've got that in here. Let's drop that off because that's just one of those galaxies from... I know why. It's because we don't have it logged. We can do that another night though. So let's drop that out. Okay, such as it is, we've picked up our focus. I think that's going to be good enough. So let's drop our camera and pull out of our, let's see, was that the camera? Drop the focuser and drop the camera, and then go back and pick it back up in SharpCap again. You know what Robin has added to SharpCap that I've not tried yet is something about interplanetary something or other. And I've just not had a chance to try it yet. Okay, let's go to Uranus really quickly. Oh, we have to connect the scope again, don't we? Let's see.
Telescope connected.
Okay, now back to Uranus. And then it refreshes. You do have to wait for it to refresh, I'm learning.
The telescope is slewing.
(62P) Tsuchinshan, also known as Tsuchinshan 1, is a periodic comet discovered in 1965, January 1st, at Purple Mountain Observatory, Nanking.
Viewing Uranus.
It will next come to perihelion on December 25th, 2023, at around magnitude 8, 6.18-year orbital period. Yeah, we want to make sure we get to Tsuchinshan. Okay, so here we are. Let's change this name to Uranus. And let's plate solve.
Viewing Uranus.
Okay, there it is in the middle. Now, I wonder if plate solving is what I was supposed to do to use the new feature. Ray, have you already done the new feature in why can't we color balance here? There we go. Oh, wow, look, you got those two moons visible tonight. That's cool, isn't it? Now, watch what happens in the atlas. In this atlas, you get a really nice view of which moons you're looking at. So see, this is Oberon here and Titania there. But if we zoom in, can you see that little, oh, you can't see anything yet, sorry. So you get Oberon right there and Titania here. But look at that little spur right there. Let me zoom in a little bit more. We're at 140%, but now our focus is better, so we can tolerate that zooming. That's the moon of Uranus called Oberon, and that's the moon of Uranus called Titanium. But look at this little spur right right there, is it? Let's see, those two moons, if they were being thrown off, I think this moon is Ariel. That's Ariel. No, maybe not. Maybe that's Miranda, and that's Ariel. And then if you look really closely, you can barely see Umbriel making another spur here. So you got 5 moons. 5 moons of Uranus in one view, but these are just visible as spurs, aren't they? But still, you can tell there's an object, and there's an object, and here is something. And then, of course, it's really easy to see Oberon and Titanium. Isn't that fun? L. So the keystroke, the shortcut key is L. L. Here we go. We could see Oberon and rats. No, I've closed that out. Oberon and Titanium. Really easily. Boy, I'm going to have to close this to open up that atlas again. I accidentally closed it with when it was refreshing. Now I have to do another quick log entry. And look, it refreshes again. But this time I'll just wait and be patient. Now I have to delete that blank one I just entered. And then I can go back and edit this one. Miranda, Ariel.
Uranus is a planet located in Aries.
Ariel and Umbriel were visible only as spurs. Uranus was so bright. All right. This was our stop at Uranus. Just kind of an on-the-way stop. Now let's go to Tsuchinshan. Oh, stop the live stacking first, Doug. Oh wait, we didn't look at the new feature. Where is it? Feature tracking, is that what it's called? No. Pete will tell me. Oh, look, Deep Sky Sequence Planner, Solar System Sequence Planner. That's cool. That's brand new. Where is this new thing? Live solar lunar planetary stacking and enhancement. That's what we're supposed to do. So let's stop this live stacking. And let's go back out to like 100%. And then let's go here called Live solar lunar planetary stacking and enhancement. Oh my goodness. How do you even use it? Target stack length frames 100. Current stack length 10. Frame stacking rate 0.3 seconds. So it decided that. Display update rate 0.3 seconds. Input frame contrast 9.8. Display frame contrast 5. Sharpening and adjustments, it automatically checked. Oh, look, it's not stacking correctly. Look, unless maybe it, no, it's just not. Yeah, our telescope tracking is still enabled. So what do you reckon is going on here? Stabilization and alignment. Oh, okay. So let's stop this. Maybe I have to zoom in on Uranus. Anybody know how to use this? Nope. Let's stop it and let's zoom in a little tighter. And see if that makes a difference. See, there are those two moons. Man, that's amazing. It's set on 3-second subframes, and we can see the, oh my goodness, look! You can see the interior moons better with 3-second subframes. Oberon, Titania. Now they're not spurs because the disk is dimmer. So you can see Miranda, Ariel, and Umbriel now. Okay, let's try this. Let's try this deal though. So how does it know which one is the planet? Show align points. Stacking mode, single point. Planet full disk. This is 27 degrees above the horizon. Look at that. It's not working. Maybe stabilize the center. Uncheck. Keep stabilizing but leave planet offset from center. Track planet with sharp cap selection area. Maybe you have to select. Oh, look, there's a help and instructions. We should have read that first. How to use. Only use for planets. Ensure entire disk is in view. Use camera region of interest or selection area to increase speed. Adjust stack length to change number of frames being stacked. Longer stacks will be less noisy, but will take longer to show changes to focus. Increase wavelets, try layers 2 and 3 to sharpen. Use save image as PNG to save sharpened image. Display frame contrast is a measure of the detail in the sharpened image. Okay, so quite obviously, we need to start over, reset stack, and we need to tell it how do you set your region of interest. I'm going to have to get Pete to explain this to me. Okay, so we're going to stop this. I'll ask my buddy Pete on the Isle of Wight and ask him to explain how that works, because it's just a little bit beyond me here, just on the fly, huh? Well, that looks like it's not tracking anymore. Do you think it changed the tracking speed? Do you think SharpCap, I bet SharpCap talked to the mount and changed the tracking speed. So now how do we change it back? Oh, there it goes. It seems to be aligned now. Okay, let's go get Tsuchinshan. So there is a place where you select a region of interest. Ray, you're saying? Camera controls. Boy, I've never done that before. Capture format and area. I'm going to have to read about that because I can't figure it out now. All right, let's go to Tsuchinshan. We're not stacking. F3 is a shortcut key, which doesn't really work out. Doesn't really work out well on my keyboard. And camera control panel on the right side. I can't find it. I'm not seeing it, Ray. Are you saying with the 20? Yeah, you have a 2600, don't you? I'm not seeing it. We're down to 36, so it's a 4-degree drop.
Viewing 62p/Tsuchinshan.
Oh my goodness. The SkyTools guy didn't know how to pronounce it either. Okay. Look at that beautiful sky. Isn't that beautiful? Wow. That's a nice view of the building I'm in. Can you see down there in the lower right-hand side, all the way to the right, there's an office window lit up? That's where I am. I'm going to go over to that window and use a flashlight and try to signal you. I'm going to say, 1 if by land, 2 if by sea. Can you see the flashlight? Can you see me? Okay, so could you see the flashlight? That's the question. But that's the window where I am. Did you see it? Good to have you here, Kevin. Oh my goodness! I just saw the delayed. Oh my goodness! It's so bright. That's funny. I just saw the delayed viewing on my iPad here. Anyway, here we are at Comet Tsuchinshan. So let's see. We need to start the sequencer. And we need to give it a name. 62P Tsuchinshan. That name is a mouthful, isn't it? (62P Tsuchinshan). Let's do
Viewing
the.
62p/Tsuchinshan.
Sounds like he's sneezing. Tiffany says, "So bright." Let's do the atlas. Wow. Look at all those galaxies. Let's figure out where we are in the night sky. So that's the one called Naked Eye, isn't it? So here's Boötes. We're looking east, southeast, at about 29 degrees. So that would be 3 fists up. If you use a fist, 3 fists up from the horizon. So if you stop and think about the North Pole there, the Big Dipper here, you could look for this kite-shaped thing and Arcturus here at the bottom of the kite-shaped Boötes. And that sort of makes a sharp left-hand turn at Arcturus to get to Tsuchinshan. It's magnitude 9.9, so it's not terribly bright, is it? So now let's get the atlas back up again. So we're in the middle of the Virgo cluster here. These are all these different spiral galaxies in Virgo. It's quite a galaxy field. So let's do this, and then this, and this, and that, and that. And right away, there she blows. Still a lot of noise in the atmosphere, but you can already see Tsuchinshan there. Now it looks like this maybe this is going to have a tail. Let's see, it's supposed to be going oh look, I think the mount is tracking the comet. Because of that thing we turned on a while ago in SharpCap. Because look, these stars are elongating, but the comet is not. That's the funniest thing ever. Look! I don't have any other way to explain that other than to think that the mount is malfunctioning. Chris says, you have a nice setup. My wife would hit me with a frying pan. Could probably justify it for the grandchildren, though. That's great, Chris. Look at the way, though, the stars are all oblonging, but the comet is not. So don't you think that something went awry when we switched to that other feature in SharpCap, and now we're no longer tracking with stars? That's all I can think of. But it sure is nice for the sake of the comet, isn't it? I had to use the fine tuning on the black level. That's when you hold down the shift key. And with the shift key hold down, now you move it with your mouse here in SharpCap. And that gives you really good fine tuning. So let's talk for a second about this gas that comes out of these comets. I thought for a long time that these were just loose snowball kinds of things, just like moving around as it flew, but they're not. They actually have a crust, and the crust has hardened, and inside the comet are these gases, but they're trapped, and the sun, because the comet's closer to the sun now than when it's out there in the what is it called? The Kuiper belt and the scattered objects, whatever that's called. When it comes close to the sun heats up all that gas, and it jets out of certain geysers on that crusty surface of the comet. So as it jets out, it like Old Faithful shooting out of the side of the comet. Some of the comet tail is actually lit up like neon is lit up. And that's like the fluorescing part. But also, you get parts of the tail that's being pushed by the solar wind and actually the force of the actual light of the sun. You know, light has this tiny force, and it's almost immeasurable, but that force of those photons and those waves is enough to push the tail. So oftentimes you get two tails. One that is the light pushing, and one that is the gravitational force of the sun fluorescing the ions of the gases. So in this case, I don't know if we're getting a tail that's pushing out this way slightly. And I don't know over the long haul if we'll be able to make that show up better. It looks like to me that if there is a tail, that it's pushing just slightly in this direction. How about you guys? One Take JDN says there could be aliens right there and we would never know. I guess so. Tiffany, it is mind-blowing. Right, ion tail, Ray says. So I think let's pull the mids back a moment, and I'll use the fine-tuning while we watch. I think if we use our imagination, there's a little more illumination over here. And I don't know which tail that is. But are you noticing the way the stars are all elongated, but the comet is not? Which just has me baffled. How is this possible? SharpCap has feature tracking turned on. And I don't even know how to turn it off now because I'm not used to this. Now over here on the right-hand side, you can see the direction that the comet's going. It's in the direction of this star. Right here. Off to the right of that star. So you notice the ion tail isn't like flowing behind the comet, like as if some lady with long hair is riding a motorcycle and her hair is sweeping behind her. And that's sort of like a mythological thing that we all think, that the comet's going so fast that this gaseous burned up tail is like the flame that's trailing behind the object, but that's not the case. Oftentimes, the comet will be going in this direction, but the tail will be pushing off in this direction because it's the sun that illuminates the tail or that pushes it with the solar wind, not the motion of the comet because it's traveling in a vacuum. And you get almost no tail from the movement of the comet itself. It's all from the fluorescing of the sun or from the solar wind pushing the particles that have been jettisoned out of the comet. Yeah, Ray, you can try these new features in SharpCap and then help me figure it out because I'm completely unprepared for it. Well, we're coming up on our last 3 minutes, sadly, of the 2 hours. It went by really fast tonight for me, but I'm just going to do a quick log entry. It's L. I could have done a shortcut key. Okay, so it didn't hear me click because it was refreshing. Here we go. So let's say, I'm going to wait and make sure it's not there. It refreshed. Oh, it took my focus away. Rats. We could see, I don't know how to spell, fluorescing gases in all directions. But it looked like the primary tail might have been flowing in the, now we can look at our atlas, and if east is this way, and that star is there, that means that the tail looks like it's flowing in almost a northwest, in a northwest direction. However, what do you call that? What do you call the center part of the comet? Is that the head or the nucleus or the coma? However, the coma was a giant splotch, at least 5 arc minutes wide. Impressive sight even at 9.9 magnitude. Pretty amazing. Hey, if you like content like this, if you wouldn't mind, go ahead and hit the thumbs up, and that way others will find our channel more easily. If you have not subscribed and you do like content like this, man, we would love that. It basically lets you know when we're doing a live stream, and you get announcements about it, or else heads up, you know. We also do an email announcement, usually as much as we can in advance, 2 nights or 1 night in advance, maybe same day sometimes, but at least 12 hours in advance when we can see the weather's going to be clear. And you get to that email list by going to emeraldhillskies.com, and there's a form you can sign up in 20 seconds. And you're not solicited, and we don't let go of your email address to anybody else. It's just for the sake of a notification list for these live streams. And if you're watching on the recording, welcome. We're glad you're here. It really means a lot that you joined us. We give a lot of thanks to God for making cool things like 62p Tsuchinshan. Tonight was like Comet, Asteroid, Planet night. And one of the things we learned is how we want to learn how to use this new planetary live stacking feature in SharpCap. So we'll research that. And we're also still learning to use Sky Tools, which is this new targeting software that has the Atlas built in. But I think you can see from the last broadcast to this one, we've already covered a lot of ground, and we hope you'll be with us again for the next time. Thanks to all of our community of folks who pitch in. You guys are so kind, Kevin and Ray, and I see you guys are again saying Coma, and Tiffany, you're like our host of the room, hostess of the room. We're thankful to God for making all these cool objects that we can see, and thankful for these clear nights so we can see them. And we're seeing them together at the very same time. It's like astronomy as a team sport. And I love that about this. We hope you'll tune back in. We try to do at least 1 night a week, the clearest night of the week we can find. We were just on Friday night. Now we're back Monday night because 2 clear nights, just 3 nights apart. We'll look for you next time, and I hope you'll come back. So good night to everybody in the community. Walter, good to have you. Chris, good to have you. Kevin, all the folks that stopped in. One Take JDN, all of you guys, Tiffany, God bless. Have a good evening, and we'll say good night for now. Take care, and thanks again to God for making all this stuff. Good night. God bless.